All right, so these videos are long because these are really long review sheets. So I'm just going to try to hit a few highlights of things I think are most important and go from there. So linear systems review, you would first put both equations into y equals mx plus b, graph them both, and you're looking for the point of intersection or the point where the lines cross, and then you write that as an XY pair. I know you guys know how to graph, so I'm not going to waste your time today graphing, and my lines are going to be, if I try to draw on this, I think it's going to be too thick. That was actually pretty straight. I'm impressed with myself. I did not think I'd be able to draw a line that straight. Okay, so solve using substitution. This was where we plug in from one variable for another, we solve. So 3 set up nice because we already have the y alone, so I can just put x plus 3 in for this y. Number 4, x is alone, so I can put negative y minus 1 in for x. This one, they're both set equal to y, so I just set them equal to each other. 4x minus 1 equals 3x plus 6. Number 6 is the hardest one on the page to do substitution. So that's the one I'm going to walk you through because it's the hardest one. So the first thing I need to do is solve one of the equations for one of the variables, which of course now I can't see the stupid equation. Come on. All right, so I'm going to solve this bottom equation for y. So we get y equals negative 3x plus 12. So I take this and I plug it in for y up here. So I would write 2x minus, and instead of writing y, I'm going to write what y is equal to. Negative 3x plus 12 equals 13. I'm going to distribute the negative. I'm going to combine my terms. I'm going to do my algebra. I find x. Oh, I'm going to sneeze. Hold on. Ow! Ow! Oh, my God, they me sneezing really loud in class. Oh, hopefully that didn't blow your eardrums out. I took my headphones off. All right, so that's x. So now I write the other equation. So I can plug back in 3x plus y equals 12. It actually doesn't really matter which equation you use. 3, 5 plus y equals 12. So I have 5, negative 3 as my ordered pair. We write our answer as an ordered pair. Then we had elimination. Elimination is the process where you line everything up and then you get two variables to cancel out. This is ridiculous with fractions. You really wouldn't see that. Oh my goodness, now I'm yawning. A really lovely video. These are all actually pretty equally easy. So let's just go to number 7 because it's the first one there. So x's are lined up, y's are lined up, equal signs are lined up, constants are lined up. So I'm good to go. I either need to get my x's to eliminate or my y's to eliminate. And actually my x's, I could multiply by negative 3 and this bottom one and they would eliminate. My y's are actually already set to eliminate if I add. So I get 4x equals 10. Well, that's not pretty. Divide by 4, divide by 4, and I'm going to get 5 halves. So now I have to plug back in. That's yucky. So let's see. 5 divided by 2 is 2.5. So 11 minus 2.5 is 8.5 divided by... Okay, so I'm going to get 8.5 divided by -2, and I'm going to get 4.25. So I get 2.5, 4.25. Not really great, but that's the way you do it. What else do we have? Oh, good, multiple choice. We don't have to graph. So the graph of the system of linear equations is shown below. What is the solution? Find where they cross. 2, 4. Helps if you have the pen. 2, 4. That's choice C. Which system has infinitely many solutions? That means the lines would be on top of each other. So you're looking for same slope, same y-intercepts. So of course you have to put them in the same format. Okay, so go ahead and do number 12. Put them in the same format. Tell me what you get. 13, which equation would make this system have an infinite number of solutions? So that's the same question as 12, which we just went over, so we'll skip that one. Use the graph to solve the system. So 14, put them in your calculator in slope-intercept form. We got to put them in slope-intercept form first. See which graph is right. Or you could pick the points and plug them in, or you could, so sorry, I'm yawning again. Or you could graph them both on your own. Okay. So pick an answer for that one. Sorry, I'll stay there so you can pick your answer. 15. George graphed the equation. Graphed one equation from a system of equations. Other equation. Okay. Let's do 15. 16. Better get that one right. Ooh, 17 is tricky. The graph of a system is shown, so we're telling you that that's a system. So what choice would you make for that one? Okay, we don't need 18. What equation? Same type of question we've already asked. Which is the first step in solving the system showing the elimination method? So try 20. 21 is the same type of question. 22 is the same type of question. So it's 23. Ooh, write a system of equations. Is all the same? Okay, so let's pick one of these. Let's pick, it looks like 24 came from an exam. Melinda spent $20.50 on 10 party favors for her party. The boys each received a puzzle book that cost $1.75 each. The girls received a magic trick that cost $2.22 each. How many boys and how many girls attended the party? Okay, so we have puzzle books, and so I'm going to say let P equal the number of puzzle books and let M equal the number of magic tricks. So puzzle books plus magic tricks should equal 10 because she bought 10 party favors. And then the puzzle books were $1.75 each. And the magic tricks were 2. That is certainly a weird number. I think it's a typo. I'm going to say 2.25 each. I don't know if that's going to give us a wonky answer, but I think it's a typo. And that was $20.50. So go ahead and solve. right. That's all we're doing for today. So we'll see ya tomorrow. Or not see ya, hear ya tomorrow. And you'll hear me. Anyways, goodbye.